All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. In this particular session, we will be discussing some of the top problems, or I would say beautiful problems of, I would say, 12th part 1 portion. Okay, 12th part first portion. Okay, so for NEET 2026, let's dive into the session. Let's understand these particular problems over here. Okay, so let me basically start from the session one over, from the problem one over here. Take a look. This is the question from electrostatics. See guys, in this particular case, it says that you have 3-point charges Q, Q and minus Q are placed at the corners of an equilateral triangle. Okay. Another charge Q is kept at the centroid. Find the force on that Q. It is simple. I will solve this in a very less amount of time. Okay. This is, I would say, a triangle. This is a triangle that I'm making over here. Okay. Yes. And my dear NEET aspirants, it says that you have on different corners, you have charge plus Q, and minus Q. It is plus Q, this is plus Q, and this is minus Q. These are the three charges. And then it says that another charge plus Q is kept at the centroid. There is one more charge which is kept at the centroid. Okay, that is this plus Q. Okay, we are supposed to find what is the net force on this center charge. Guys, see. First and the foremost thing, this plus Q is going to repel this plus Q. This plus Q is going to repel this plus Q in this direction. This will repel in this direction. And this minus Q is going to attract. So I can say, so on this force will be something like this F. On this force will be something like this F. And this minus Q is going to attract with the force F. And I have told you previously, this angle between this F and this F, it is actually 120 degrees. So now if between this F and this F is 120 degrees, so their resultant will be also F. Now what is the net force acting on the center charge? I can say 2F. Now you can write over here, that is 2. What is F? F is basically force between any two charges. If let's suppose I'm saying side over here is A. What is the distance between corner to the center? From the corner to center? A divided by root 3. In case of an equilateral triangle, it is A by root 3. Now, what is the force between this charge and this charge? Since you said F, let's find F. So F will be K, Q1 is Q, Q2 is capital Q divided by R square. Distance between the two is A divided by root 3. So we have to do it square. So A square by 3. Take this in the numerator. 3 2s are 6. K Q Q divided by A square. This is going to be the answer. Even you can further write it like this also. So this is 6 Q Q divided by, instead of K, you can write 4 pi epsilon naught into A square. Okay. Now, my dear NEET aspirants, so this you can say the answer in this particular case. 2 2s are 4, 2 3s are 6. 3KQ, okay, 3QQ divided by 2 pi epsilon naught into A square. You can write it like this also. Now, let's move on to this particular question. There's a question number 2. Two equally charged identical metal spheres A and B repel each other with a force F. Okay. Okay. Yes. You have got two metal spheres. You have got two metal spheres. Understand this very carefully. This is A and this is B. They repel each other. Let's suppose they are placed at a distance R. They repel each other with a force F. Okay. So what is the force between the two? K, and charge on both is Q, and this is Q. Q into Q is Q square divided by R square. This is the force. Then it says another identical uncharged sphere C is touched with A. There is one more sphere C which is touched with A and then placed midway between A and B. Another sphere, let's suppose I'm saying that is, this is C. This is uncharged. You are touching this with A and then you are placing it over here midway. Then I'll make the new diagram somewhere around over here. See. So this is going to be A, this is C, and this is going to be B. And one more important thing. When C is touched with A, they will share the charge between each other. This is C, they'll share the charge. What is the net charge here? Q. Q is on this. When C is touched, C is uncharged, it will give half of the Q to C. So now on this, it will remain Q2. On this, sorry, Q by 2, and on this it is Q. And this distance is R by 2. This distance is also R by 2. Okay. Now, my dear NEET aspirants, in this particular case, what you are supposed to do, you have to find the force on, then the net force on the C will be, okay. Guys, see, tell me, when it comes to this C, we say this B is applying the force on it, that will be force due to B, something like this. And A is also applying force, this will be force due to A, something like this. If I say what is the force due to, guys, see, what is the force due to A? What is the force due to A? You simply say, sir, force due to A will be force between this and this. That is K, Q by 2 into Q by 2 means Q square by 4 upon R square. That is R square by 4. 4 and 4 will cancel. So it will come out to be Q square divided by R square. Okay. Then, my dear NEET aspirants, FB, force due to this, that is force between this and this. So I can say this FB will come out to be K Q1 Q2, that is Q divided by 2 into Q divided by R by 2 whole square. So this FB will come out to be K Q square by 2 into R square by 4. 2 ones are 2 twos are. Take this 2 in the numerator. So this will be 2 K Q square by R square. This FB. Now FA is KQ square by R square. FB is 2 times KQ square by R square. Listen to me very carefully. So can I say, when it comes to the net force will be simply, that is FB minus FA. Yes, sir. Bigger minus smaller. So this is 2 times of KQ square by R square minus KQ square by R square. So this will be 2 times 2 minus 1 is 1. So it will be KQ square by R square. And this is F. Because we have already said in the starting itself, KQ square by R square is F. And what is the direction of net force? Guys. Direction of net force is always the direction of bigger force. So FB is bigger as compared to FA. So direction of FB is towards A. So I would say this F is net forces towards A. Okay, it is towards A. F towards A. Let's move on to the next one. See, guys. 2 small spheres, each having charge plus Q, are suspended by an insulated thread of length L from a hook. The arrangement is taken to a gravity-free space. This arrangement is taken where? To a gravity-free space. See, guys. You have 2 suspended charges, this one and this one. This is Q and this is Q. What is the force acting in the downward direction? mg. What is the force acting in this direction? That is electrostatic force. And length of this is L. Now, if we take the entire system to the gravity-free space, if we take this to a gravity-free space, okay, let me show you the gravity-free space. Okay, sir, when it comes to the gravity-free space, there will be no mg, means no gravitational pull will be there. So when there is no gravitational pull, so this electrostatic force, on this also electrostatic force in the downward direction mg. Here gravity is present, but when you put it over here, we say due to these 2 electrostatic forces, it will look something like this. So on this, electrostatic force will be acting in this direction, electrostatic force will be acting in this direction. And in the inward direction, there will be tension. This is the length L. Now first, if they are placed in a gravity-free space, what is the angle between the 2 strings? The angle between the 2 threads, that is 180. Theta is 180. And when I say this electrostatic force will be actually equal to tension. Why? Because the charge at this point is in the equilibrium. So that means outward force will be equals to inward force. Outward force is electrostatic force, K Q square by R square. Inward force is tension. So this will balance. And when it comes to electrostatic force, that is K Q square. This is Q, this is Q. K Q into Q is Q square divided by R square. And guys, this length is L, this length is L. L plus L is 2L. So I can say 2L whole square. So this will be K Q square divided by 4L square. This is going to be the electrostatic force. This is going to be the electrostatic force. Now you have this question. Find the horizontal and vertical component of the electric field. Find the horizontal and vertical component of the electric field. This is the question. Okay. Now, my dear NEET aspirants, how you guys are supposed to find the horizontal and vertical components of the electric field in this particular case? Listen to me very carefully. This is over here a chord. This is a chord which is given. First and the foremost thing, you tell me what is the electric field at this point. Due to the chord, electric field at this point is root 2 K lambda by R. Okay. Okay. So we say this electric field due to the chord is root 2 K lambda by R. I'll make it over here. This is a chord. If I say what is the electric field at this point, you say this is a root 2 K lambda by R. A root 2 K lambda by R. Okay. Yes. Now, my dear NEET aspirants, if this is root 2 K lambda by R, this root 2 K lambda divided by R. Tell me one thing, boys and girls. This will have two components, this horizontal and this vertical. We have to say what is the horizontal and vertical. See, it is like this. If let's suppose you have force F, we say or you make it like this, see. If let's suppose, my dear NEET aspirants, you have force F, we say resultant of the two will be root 2 of F. Resultant of the two will be root 2 of F, because we know at 90-degree angle, theta, if theta is 90, angle between F and F, so we say resultant will be root 2F. Now you can understand it like this also. If resultant is root 2F, its horizontal component is F, vertical component is F. Similarly, if resultant is root 2 K lambda by R, don't you think that horizontal component will be K lambda by R? This is vertical. Horizontal will be also K lambda by R. Horizontal is K lambda by R, vertical is also K lambda by R. So then only we say net is a root 2 K lambda by R. So this is the answer to the question. Horizontal and vertical components of the electric field, K lambda by R, K lambda by R. Okay. Let's talk about this question. Find the net electric field. Guys, this is a semicircular ring. On this semicircular ring, we say charge is distributed on this chord. So you can break this in two chords. Because charge is distributed on the chords over here. So we can say electric field due to this chord at this point will be away from the chord. And how much? Root 2 K lambda by R, because electric field due to a chord is root 2 K lambda by R. Okay. Electric field due to this chord is root 2 K lambda by R. Just a second, guys. Just a second. It is a root 2 K lambda by R. Okay. Yes. Now, my dear NEET aspirants, what I can say in this particular case, and this is away from the charge. Because why this is away from the charge? Because this is a positively charged ring. Due to positively charged ring, electric field is away from the ring. Since due to this negatively charged ring, electric field is towards the ring. And that is how much? Root 2k lambda by r. Now, this angle is also 90. If angle between the two vectors is 90 and both are similar, this is root 2k lambda by r, root 2k lambda by r. Like it is like if this is f, this is also f, a resultant is root 2f. If this is x, a resultant will be root 2x. Now, if this is root 2k lambda by r, root 2k lambda by r, in this particular case, my dear NEET aspirants, this is going to be a root 2 of a root 2k lambda divided by r. So root 2 into root 2 is 2, and then we say k lambda by r. This is going to be the resultant in this particular case. I believe this is crystal and clear. This one is simple. This I'll give you as homework. Let's move on to the next one. And its answer is 0. Net electric field is 0. Please do check it from your end. Let me ask you this particular question. Okay. See guys. The question over here is, let me write it in this way. See. The question is, you have got an infinitely long rod. Okay. Yes, this is an infinitely long rod. Okay. Now, my dear NEET aspirants, this is infinitely long rod. And in this particular case, what I'm saying is that this is a basically charge which is placed over here, which is rotating in circle. So there is a charge minus q over here and its mass is m. Okay. Charge on this rod is plus lambda. That is positive. And it is at, I would say, r distance. My question to you is, what should be the velocity? What should be the velocity given to the charge? What should be the velocity given to the charge so that it completes the circle? What? It is a rod. It is a minus q charge. How much velocity we must give to the charge so that it completes its move, it moves in a circle? See guys, always remember, whenever a charge performs circular motion, centripetal force acts on it. And that centripetal force is mv square by r. And my dear NEET aspirants, in this particular case, since there is a rod wire, and on this wire we say charge is positive. We said due to this rod also force will act on this, electrostatic force. And that electrostatic force will be Q times of E. And every single time, I have told you many times, make this centripetal force equal to electrostatic force. Here centripetal force is created by electrostatic force only. So we say both will be equal. So I would say Fc will be equals to mv square by r. So I would say Fc equals to Fe. So electrostatic force will act because the wire and the charge is there. They have electrostatic attraction. Centripetal force will act because they are performing circular motion. Now this is mv square by r is equal to electrostatic forces Q times of E. Okay. Now E, what is E? E is the electric field due to this wire. Guys, when you say charge is Q times of E, charge is Q. E is the electric field due to this wire at this point. What is the electric field due to an infinitely long wire? 2k lambda by r. So we can write mv square by r is equal to Q. Then we say 2k lambda by r. R and R will cancel. So V square will come out to be 2kq lambda divided by m. Then we can say V will be equals to under root of 2kq lambda divided by m. This will be the value of velocity with which it moves in a circle and it completes the circular path. Okay. Okay, this question. This is the simple one. This is your homework. Let's take a look at this. Now, my dear NEET aspirants, in this particular case, This is a cylinder. Inside the cylinder, you have this charge Q. If I say, what is the net flux through the cube, through the cylinder? You say, sir, Q by epsilon naught. And that flux will be through this surface, plane surface, through the curved surface, through the curved surface. That flux is through curved surface, and that flux is through this plane surface. Okay. So when you write flux through the closed cylinder, flux through the closed surface means cylinder. It is how much? Q divided by epsilon naught. When you say this flux through the cylinder, it means flux through two plane surfaces plus flux through one curved surface. That is Q by epsilon naught. Now, flux through two plane surfaces, and guys, flux through curved surface is given as phi naught. Let's consider it phi naught plus phi naught is equal to Q by epsilon naught. Now take this phi naught over there. So we'll be saying flux through two plane surfaces will be equals to Q by epsilon naught minus phi naught. So flux through one plane surface will be equals to 1/2 of, I would say, Q by epsilon naught minus, I would say, phi naught. This is the flux through one plane surface. This is the flux through one plane surface. Okay. If I say, this is a question from JEE 2010. In this particular case, you have to tell me what is the flux through ABCD phase. ABCD phase is this much, this one. This is ABCD phase. This one. Now see, in this case, my dear NEET aspirants, there is a charge placed inside, there is a charge placed outside at the same distance. We say if electric flux through this charge, the amount of field due to this charge, the flux will leave from this inner charge, which goes out, something like this. This charge is also at the same distance. From this charge also we say electric field lines will come out. And those electric field lines will cross this phase. Electric field due to this will go out. Electric field due to this will come in. So we say in this particular case, net flux through ABCD is 0. Net flux through ABCD is 0. Okay. Net flux through ABCD is 0. This is a question of JEE Advanced 2014. Okay. In this particular case, you guys are supposed to tell me what is the electric field at point P in all the three cases. These are the three spheres. Okay. And in these three spheres, you can clearly see, my dear NEET aspirants over here. You can clearly see, my dear NEET aspirants over here. That is, here point lies outside, point lies on the surface, here point lies inside. Okay. Outside, surface, and then we say inside. Outside, surface, and then we say inside. Okay. Yes. Now, boys and girls, what I'm trying to say over here is, just a second. I'm arranging this. Okay. See, guys, what I'm trying to say in this particular case is, see, what is the electric field at this point outside? In first case, sir, electric field due to a solid sphere is given. Outside is, that is KQ divided by small r square. This is the electric field due to a solid sphere outside. Okay. Yes. And here charges, I would say, and it will be same only. Let's call this as E1. And let's consider this as point 2, electric field on point 2. What is the electric field due to a solid sphere on surface? KQ by capital R square. And here it will K, Q is charge, that is 2Q, divided by capital R square. Capital R is the radius, that is R square only. This is E2. Okay, absolutely, sir. Then, my dear NEET aspirants, we say electric field at point 3 in case of this. That is inside. Electric field inside is KQ small r divided by capital RQ. And then I can say over here, this is KQ into small r. Okay. KQ small r. Then, my dear NEET aspirant, and what is small r? Small r is the distance inside where you have to find the electric field, that is r. So small r will be over here, capital R divided by capital R cube. Capital R means the radius, so that will be 2r whole cube. So what you can write over here, E3 will come out to be, that is KQR divided by 2r cube, that is 8. And by the way, guys, oh, one thing I forgot. Charge in this particular case, charge is given as 4Q. So that is 4KQ. This is 4KQ, 8R cube. 4 ones are 4 twos are R, and here it will be R square. So electric field at point 3 will be KQ divided by 2R square. KQ divided by 2R square. Okay. Now, guys, this is the electric field at point 3, electric field at point 2, electric field at point 1. If I say where is the electric field more? Electric field is more at 2. Then electric field is more at 1. Then electric field is less than, I would say, 3. This was the question which you were supposed to solve. Find the value of sigma. Okay, if the charge is in the equilibrium. If the charge is in equilibrium. Find the value of sigma if the charge is in the equilibrium. You have to tell me what is the value of this sigma if the charge is in the equilibrium. Now, my dear NEET aspirants, if the charge is in the equilibrium, so basically this is the sheet. This sheet is having the charge density sigma. You have to tell me this sigma only. Now, what you have done exactly over here is, you have a sheet, you have attached a wire to the sheet. Charge Q is placed over here, mass is M. And in this particular case, what I'm trying to say is that you have to tell me what is the value of sigma if this is the equilibrium. If the charge is in the equilibrium, how many times? I have told you net force will be 0. So balance the forces. So what are the forces acting on this one? In the downward direction, it will be mg. And in the outward direction, this is going to apply the force. In the outward direction, this is going to apply the force, that is Q times of E, electrostatic force. And in this string, it will be tension T. If this angle is theta, we know this will be also theta. And this component will be T cos theta. And this component will be T sin theta. Yes. Now tell me which components will be equal. So I would say T sin of theta will be equals to Q times of E. And T cos of theta will be equals to, I would say, M into G. T cos theta will be equals to M into G. Okay. Yes. Yes. Now divide the two. When you divide the two, this T and T will cancel. Sin by cos is tan theta. It will be equal to QE divided by mg. Now tell me, E is the electric field due to this charge sheet. And since it says it is a conducting plate, due to a conducting plate, electric field is sigma by 2 epsilon naught. Sigma by epsilon naught. Okay. Electric field due to the conducting plate is sigma by epsilon naught. So you can say tan of theta will be equals to Q. Instead of E, you can write sigma divided by epsilon naught into, I would say, mg. Take it over there. Take it over there. So sigma will come out to be mg epsilon naught tan of theta divided by q. This is the value of sigma. This is the value of sigma. Is that clear? Okay, let's move on to this one. This is a simple question. Dipole. Let me move on to. Okay. This I'll give you as homework. You have to find the net dipole moment over here. Let me just give you the hint what you guys are supposed to do. So here it is charge minus q. Here it is charge plus q. Here it is charge plus 2q. Here it is minus 2q. Here it is minus 2q. Here it is plus 2q. Okay. Now, my dear NEET aspirants, you break this. Now you can say this is a dipole moment here will be P. Dipole moment here will be 2P. Dipole moment here will be 2P. Now you can find the resultant. Let's take a look at this question. You have basically a dipole. There is a dipole which is given exactly over here. Okay. I want you to understand this very carefully. There is this dipole. Just a second. There is this dipole. Okay. This is the dipole which is given over here. See, this is the dipole. You have to tell me what will be the electric field at point A. What will be the electric field at point B? A point and B point will be the general. A point will be the general point over here. Okay. A point is going to be the general point over here. A point is going to be the general point over here. So what I want you to understand in this particular case, when I say electric field at the general point, what is the electric field at a general point due to an electric dipole? Due to an electric dipole. It'll be simply saying that is Kp divided by x cube under root of 3 cos square theta plus 1. This is the formula. Now what is the value of theta over here? That is 45. And this x is the distance from the dipole till that point. So x will be equals to root 2L. Because if the side is L, hypotenuse is going to be root 2L. So electric field at A will be, that is Kp divided by x is root 2L, its whole cube. Then I would say under root of 3 cos square of 45 plus I would say 1. Plus I would say 1. Now electric field at point A will be Kp divided by root 2L whole cube. What does that mean? That means root 2 whole cube. It is 3 times root 2. Root 2 into root 2 into root 2. Okay. So let's keep it like this only. Root 2L whole cube. Then I would say under root of 3 cos square 45. Cos 45 is 1 by root 2. Okay. So when you put the square, it will become 1 by 2. So it will become 3 by 2. So 3 divided by 2 plus 1. So overall it will become 5 by 2. Overall it will become 5 by 2. Now, how many root 2's here? A root 2 3 times, a root 2 1 times. Total is 4 times root 2. So into root 2. So see, it is like a root 2 into root 2 into root 2 into root 2. Root 2 into root 2 is 2. Root 2 into root 2 is 2. 2 into 2 is 4. Overall, it is 4. So answer is going to be Kp divided by L cube root 5 divided by 4. This is going to be the answer. This is going to be the answer in this particular case. I believe this is clear. This also I'm giving you as homework. Okay, it is simple, bro. What is the electric field? What is the ratio of electric field at a point on the axis? Electric field on the axis of the dipole. 2Kp divided by x cube. and equidistant point, that is equatorial point. Electric field at equatorial point is Kp divided by x cube. Divide the two. Just a second. At equatorial point, it is Kp by x cube. Now divide the two. So I can say electric field on the axis divided by electric field on the equatorial point. This is the question of NEET 2022. So this will be 2Kp divided by x cube upon Kp divided by x cube. So what you will do in this case is x cube, Kp, Kp. So it will be 2 is to 1. 2 is to 1, 2 is to 1, 2 is to 1, 2 is to 1. Okay. You. This question, take a look at this question. In an electric field, another charge Q is carried. Another charge Q is carried from A to B, A to C, A to D, then the work done will be. See guys, what does the question say? There is a charge placed over here, that is this Q. This is the charge placed. Okay, this is the charge placed. Just a second, guys. Okay. Let's take a look at this guys. In this particular case, okay, let's take a look. This is a charge over here. There is a charge over here, Q. Okay. It says another charge Q is taken from A to B. What will be the work done? Let's see. If we take the charge from A point to B point, what is going to be the work done? Okay. Understand this very carefully. When it comes to A point to B point, when it comes to A point to B point, if you take the charge from A to B, okay, in that particular case, work done will be, okay, that is change in potential energy. I have told you so many times, work done is change in potential energy. That is simply final potential energy minus initial potential energy. So initially it was here at this point. Initially it was at this point. Finally it is at this point. Now initially when it is at this particular point, what is the distance between the two r? So what is, I can say, what is the final potential energy? Finally it is here. So what is the final potential energy? K Q divided by R minus. Initially it is here. So this is one charge Q, this is another charge Q. So K Q divided by R. So potential energy is 0. Okay. See, what I'm trying to say is that this will be the final potential energy. Let me write final first. So final minus initial. So I can write work done will be final potential. Final is here. So that is K Q square by R. Initial is K Q square by R. This and this will cancel. So work done in this particular case will be 0 along AB. Even by using the same approach, along AC will be 0. Along AD will be 0. Along AE will be 0. So I can say work done in along all the paths is 0. Okay. Let's suppose if they ask you the question something like this, find the work done in rotating the dipole. Find the work done in rotating the dipole from theta 1 to theta 2. Okay. If they rotate the dipole from theta 1 to theta 2. Okay. Yes. If they rotate the dipole from theta 1 to theta 2, you guys are supposed to find the work done. This is the dipole. This is the dipole. This is the dipole placed here. Now guys, in this particular case, initially the dipole is something like this. It is making an angle of 60. Finally, the dipole is something like this. It is making an angle of 120 because we checked the angle with x-axis. So when I say in this case, guys, work done, when I say work done is delta U, change in potential energy. That will be final potential energy minus initial potential energy. And that is going to be final potential energy. Guys, finally it is at an angle of 120 degrees. So what is the potential energy of a dipole? That is minus PE cos theta. So finally angle is 120. So potential energy of the dipole is minus PE cos theta. Final potential energy is minus PE cos of 120. Then minus. Initial potential energy is initially how much angle? 60. Minus PE cos of 60. Now guys, you can say minus PE cos 120 is minus 1 by 2. Minus into minus is plus. PE into cos 60 is 1 by 2. Minus into minus is plus. So I can say PE divided by 2 plus I would say PE divided by 2. That is going to be PE. This will be the potential energy in this particular. This will be the work done. This will be the work done. Because work done is change in potential energy. This is simple. This also I have told you previously in the capacitors. If n small drops, you have got n small drops, n small capacitors are joined to form a big capacitor. If n small drops are joined to form a big capacitor. What is the capacitance of big capacitor? N raised power 1 by 3 into C. What is the potential of big capacitor? N raised power 2 by 3 into V. If you remember, I have told you this previously. Now here capacitance, and what is the value of N? 64. So C dash will be equals to 64 raised power 1 by 3 into C, where C is the capacitance of the small capacitors. Where C is the capacitance of small capacitors. So C dash will be equals to 64 is 4 cube whole raised power 1 by 3 into C. 3 and 3 will cancel, so it will be 4C. Okay. Okay. Then the capacity of the big drop will be how many times? 4 times. 4C. Okay. Let me see some of the good questions over here. This is the question which was actually asked in. This is the question which was actually asked in JEE Mains 2021. This is a question of JEE Mains 2021. Let me add one more slide over here. This is the question of JEE Mains 2021. Read the question very carefully. For changing the capacitance of a given parallel plate capacitor, a dielectric material of dielectric constant K is used. We have used a dielectric material of dielectric constant how much? K. Which has the same area as the plates of the capacitor. Okay. The thickness of the slab is 3D by 4. See guys, you are given a parallel plate capacitor. Okay. And in this particular case, a dielectric slab is inserted. There is a dielectric slab which is inserted. And its width is 3D by 4. And total gap between the capacitors is D. Gap between the plates is D. Now, if this is 3D by 4, how much is going to be this? This will be D by 4. Absolutely, sir. Because 3D by 4 plus D by 4 is how much? D. Yes, sir. Absolutely, sir. Now, tell me, boys and girls, one thing. And it says this has dielectric constant K. And from this side, there is no dielectric constant. It will be air. So for air, dielectric constant is 1. It says what will be the capacitance of this new capacitor. See, guys. You'll be using this formula. Consider these are the two slabs placed inside between the two plates, this slab and this slab. So you'll be saying C dash will be epsilon naught, okay, epsilon naught into A upon D1 by K1 plus D2 by K2. This is the formula which we use when dielectric slabs are placed in the series. Here dielectric slabs are placed in series. So C dash capacitance will be epsilon naught A upon D1 by K1. D1 is the width of first dielectric, K1 is the dielectric constant of first dielectric. D2 is the width of second dielectric, K2 is the width of second dielectric. So D1 by K1, that is going to be 3D divided by 4K plus D divided by 4. Because it says D1 by K1. So 3D by 4 is divided by K. K is for this. Then D by 4. So what will you do in this particular case? Epsilon naught A upon. Take this D divided by 4 common. So what remains? 3 by K plus 1. Okay, let me write it over here. Okay, yes. This is C dash. Now this will be epsilon naught A upon D divided by 4 K plus 1. So this will be 3 plus K divided by K. Take this in the numerator. It will become 4K epsilon naught A upon D into 3 plus K. Now see, this epsilon naught A divided by D, this is what we call C naught. This is the capacitance of a capacitor without dielectric. So you can write C dash is equal to 4K C naught divided by 3 plus K. 4K C naught divided by 3 plus K. 4K C naught divided by 3 plus K. I believe this is clear. Okay, let's move on to the next question. Okay, let's talk about this. So you have to tell me, find C equivalent, means equivalent capacitance. You have to tell me, find C equivalent capacitance. Now guys, see, you can see clearly the plate is connected over here. Another plate is connected over here. This plate, this plate. Now see, how many capacitors are formed? You see, we say potential of this, if this is the point A, if this is point A, potential of this point is A. We say it is connected to this. This will also have the same potential A. It is connected to this. This plate will also have the same potential A. This potential is B. If this is B, this plate will also have the same potential B. This plate will also have the same potential B. So what I'm trying to say in this particular case, my dear NEET aspirants, we say how many capacitors are formed? Two plates form one capacitor. So this is first capacitor between A and B. And this capacitor between this plate and this plate, it will be short circuit. Why? Because potential is same. Potential of this plate is B, potential of this plate is B. So you don't write this. So you have got two capacitors over here. Okay. And how many points? We say A and this is B. So you see, this capacitor is connected between A and B. Even this last one is connected also between A and B. So it is like this, between A and B. Both are connected between A and B. This is C and C. When capacitors are in parallel, so C equivalent will be 2C. C equivalent will be 2C. Okay, yes. C equivalent will be 2C in that case. Like you have over here. Guys, what is the equivalent capacitance between A and B? Find C equivalent between A and B. Find the equivalent capacitance between A and B. See, first and the foremost thing, these three are in series. Okay. These three are in series. So C and C are in series. So when the capacitors are in series, their equivalent will be C by 3. Okay. Now see, I can redraw it. I can redraw it. This one. Okay. This is A. This is C divided by 3. And this is C. This one I am showing over here. And here this potential is B. Now you tell me one thing, boys and girls. Potential of this is A here. It will go directly here. Even directly till over here, here potential is also A. Potential of this point is B, so here this point is also B. Now the two capacitors are connected between A and B. Now the two capacitors are connected between A and B. Okay, yes. Now the two capacitors are connected between A and B. And boys and girls, you can clearly see in this particular case between A and this B, this C by 3 is connected. Between this B and A, C is connected. So they are in parallel. C by 3 and this C. Okay. So what is C equivalent? When it comes to the parallel combination, C equivalent is simply C1 plus C2. So that is C divided by 3 plus C. 3C plus C is 4C divided by 3. This is the equivalent capacitance. Okay. Yes. Let's suppose you have this question. This is a question from current electricity. And you are supposed to find what is the potential difference between A and B. What is the potential difference between A and B? You are supposed to find what is the potential difference between A and B. Guys, see. Whenever you have to find the potential difference between one point and another point, you first thing you select the path. Select the path. This is the first thing that you are supposed to do in this one. Okay. Yes. Absolutely. Then, my dear NEET aspirants, move from that point to another point. Move from that point to another point, like from here to here. This has to be your path from A to B. And you have to write the potential drops. What is the potential of point A? That is VA. First one. VA. Absolutely, sir. Then, my dear NEET aspirants, we say this is the direction of current. Current always flow from higher potential to lower. So that's why I'm saying plus minus. Here, current will flow from higher to lower. Okay, that is plus minus. Okay, one more important thing, guys. Here it says 3 ampere current is leaving. 1 ampere current is leaving, 3 is leaving. 3 plus 1 is 4, means 4 must be coming. Kirchhoff's current law. The amount of current which enters the junction is the same amount of current which leaves the junction. The amount of current which enters the junction is equal to the amount of current which leaves the junction. Okay. Yes. Now, if this is 4 ampere, here also it will be 4. Now see guys, 2 ampere is coming from this side. If 2 ampere is entering this junction, is it possible that 4 ampere can leave? No. So means 2 must be coming from this side. Yes, sir. I agree, sir. So means this will be higher potential, this will be lower potential, because current always flow from higher to lower. Because current always flow from higher to lower. Okay. Current flows from higher potential to lower potential. That is what is happening over here. From this positive to this negative. Okay. Now first you write the potential of VA, potential of this point A. First you write the potential of point A. Okay. Then my dear NEET aspirants, what you do in this particular case is over here. We say you write then potential drop in this resistor, that is I into R. What is the current over here? 2. R is 4. So that is 2 into 4, that is 8. 8 volts. Potential difference in the resistor is how much? I into R. I is 2, R is 4. And you see the path. You are moving from higher potential to lower. You are moving from higher to lower. You are moving from plus to minus. You are moving from plus to minus. If you move from plus to minus, my dear NEET aspirants, you take potential drop as negative. You take potential drop as negative. You take potential drop as negative. So you'll be mentioning over here, this will be minus 8. This will be minus 8. You'll be taking potential drop as negative, minus 8. Then my dear NEET aspirants, if you are taking this as minus 8, listen carefully. Listen carefully. Then you reach here. Here you are going from, this is, I would say, from negative to positive. This is higher, this is lower. In case of battery. So when you move from lower to higher, you will be taking plus 3 volts. Yes. Then come here. You are moving from higher to lower in this case. Higher to lower, that is I into R. I is how much? 2. R is 2. 2 into 2 is 4. So I'll be writing minus 4 volts. Why? Because you move from higher to lower. Okay. Yes, sir. Then my dear NEET aspirants, then you reach this point. Then here in this resistor, how much is the current? That is 2. Resistance is 1. So 2 into 1, I into R. That is 2 into 1 is 2. And you move from lower to higher, because this is your path. This is plus 2 volts is equal to, final point will be is equal to VB. Okay. Yes, sir. Yes, sir. I can say it something like this. Now, minus 8 minus 4 is minus 12. So VA minus 12. 3 plus 4 is 7 minus 7 plus 7 is equal to VB. So VA, this is minus 5 volts is equal to VB. So VA minus VB will be equals to 5 volts if you take it over here. Okay. Did I make any mistake somewhere? 2 into 4 is 8. Okay. This is minus 8. This will be plus 3. Okay. This 2 into 2 is 4, minus 4. Then 2 into 1 is 2. And it is plus 2. Okay. 12 minus, this is 5. 3 plus 2 is 5. I made a mistake over here. That's why. This is 5. This will be 7. This will be 7 volts. So answer in this particular case came out to be 7 volts. Answer in this case came out to be 7 volts. This you can do from your end. If I say what is the potential difference between A point and B point, you can do it. You can do it. Okay, select the path from A to B. And if this is a 5 ampere current coming from top, okay, Sir, 2 ampere is going to this side. So if 5 is coming, 2 is leaving. Is it possible? No. So 5 must leave. So from this side, it is 5 ampere. Oh, sorry, 3 ampere. It is 3 ampere. So 3 plus 2 is 5. 3 ampere plus 2 ampere is 5 ampere. Okay. Yes, I believe. Yes. Now you can do it. Now it is very simple if you move from A point to B point. Okay. Find the potential drop in each resistor. We say law of potential drop. Use law of potential drop. Law of potential drop. What does law of potential drop say? V is directly proportional to R in series combination. The one which has large resistance will have more potential difference. Now, which one is large? This will have large potential difference. This less, this less. The one which has less, assume it X. If this is X, so 6 is how many times bigger than 3? 2 times, so it will be 2x. 18 is how many bigger than 3? 6 times, so it will be 6x. Okay, 6, 3, 18. So I can say 6 plus 2 is, so this is basically V1 potential difference. This is V2 and this is V3. V1, V2, V3. Now, my dear NEET aspirants, what I'm trying to say in this particular case over here is, listen carefully. I can say this net potential difference will be equals to V1 plus V2 plus V3. Net potential difference is 10 volts. It will be equals to X plus 2X plus 6X. 6 plus 2 is 8 plus 1 is 9. So 10 is equal to 9X. X will be equals to 10 divided by 9 volts. So X will be equals to 10 by 9 volts. Then this is the value of V1. This is the value of V1. If I say what is the potential difference V2, guys, what is V2? V2 is the potential difference across second. So you'll be saying V2 will be 2x. That is 20 by 9. V3 will be equals to 6x. That is 60 by 9. Now, guys, let's do one thing. Let's move on to this question. Okay, this is law of current drop question. If 10 ampere, okay, law of current distribution. What does law of current distribution say? Let me just tell you over here. Law of current distribution says, we say according to law of current distribution. Law of current distribution. According to law of current distribution. Listen carefully. It says I is inversely proportional to R in parallel combination. The one which has large resistance will have less current, will flow less current in that. Which one has large resistance among the two? Which one has large resistance? I would say 8 has large resistance. So current will be less. And let's assume over here in this, it will be X. Now 2 is how many times smaller than 8? 4 times. So it will be 4X. So this is I1, this is I1 and this is I2. And this is net current. So net current is divided into I1 and I2. So we can say net current here will be I1 plus I2. Net current is 10. I1 is X, I2 is 4X. So 10 is equal to 5X. 5 ones are 5 twos are. So X will be equals to 2 ampere. If X is equal to 2 ampere, what will be I2? I2 will be 2X. So that will be 2 into 2 is 4 ampere. Oh, sorry, it is 4X, 4X. I2 is 4X. 4X, that is 4 into 2, that will be 8 ampere. And this is I1 is equal to 2 ampere. Yes, 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 yes. Let's suppose you have this question. You have to tell me what is the current here. What is the current here? Current in this. You have to tell me what is the current in this. See guys, here it is. This is what we call grounded. Here it is 0 volt potential. Here it is 0 volt potential. Now, my dear NEET aspirants, if this is a 0 volt potential over here, in this particular case, okay, we say here also potential is going to be 0 volt. Okay. Now, if this is 8 and this is 0, what will be the potential of this end? We always say higher potential minus lower potential. This higher potential minus lower potential will be equals to potential drop. So this will be equals to 8 volts. 8 volts. Sir, how? Let me show you how. If this is a battery, this is 8 volt battery. You have to tell me potential of this, and potential of this end is 0 volt. What will you say? Higher minus lower. That is V minus 0 is equal to 8. So V will be equals to 8. V will be equals to 8. Okay. Yes. 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 Now, if this is 8, this is 4, how much will be the potential of this? Minus 4 volt. Plus 4, plus 4. Why? Because 8 minus 4 is equal to 4. So, difference between higher potential and lower potential must be equal to this. Now, what should I keep the potential here so that the difference comes out to be 6? Let's keep minus 2. Now see, higher minus lower. Higher is 4 minus, lower is minus 2. 4 minus into 1 is plus, so it will be plus 6. So that is 6. Okay. Now, since you have to find the current in this, whenever you have to find the current in this, do this method only. Draw potential of every point. So potential of every point came out to be like potential of this point. You got potential of this. Now tell me what is current. I is delta V by R. Delta V is potential difference. What is the potential difference across this resistor? That is 8 minus 2 minus of minus 2. Higher potential minus lower potential divided by resistance is 2. So that is 10 by 2. That is 5 ampere. 5 ampere. Okay. Absolutely, sir. Okay. Let's suppose you have this question. This is a question from magnetism. This is a question from magnetism. The question over here is, you have to tell me in this particular case, what is the net magnetic field over here? Current in the wire is flowing something like this. This is the current I. And let me just tell you, you are supposed to consider these as, just a second. You are supposed to consider these as semi-infinite wires. These are the semi-infinite wires. See. You find current due to one wire, then multiply with 2. Because this is one wire, this is another wire. You find current due to one wire, multiply with 2. What is the magnetic field? You find magnetic field due to one wire, multiply with 2, you'll get the net magnetic field. What is the magnetic field due to a wire? Magnetic field is mu naught I divided by 4 pi r. Then we say sine of theta 1 plus I would say sine of theta 2. This is the magnetic field due to wire. Yes, this is the magnetic field due to wire. Now, my dear NEET aspirants, in this particular case, what I'm trying to say is that when it comes to the magnetic field here, okay, when it comes to the magnetic field here, we say this is mu naught I divided by 4 pi current. Let's find the magnetic field due to this wire. Current is I. And this distance, this is given as r. So I'll be using this as r. Then we say sine of theta 1. What is the angle theta 1 over here? This is theta 1. And theta 2 will be, guys, how do we make theta 1 and theta 2? Join that point with one end of the wire. Join that point with another end of the wire, which is at infinity. So theta 2 will be 90. So we say sine of 45 plus I would say sine of 90. Okay. So magnetic field will be mu naught I divided by 4 pi r. Sine 45 is 1 by root 2. Sine 90 is 1. Okay. Let me just wait. Yes. Okay. So when it comes to the net magnetic field will be 2 times, because these are two wires, 2 times of mu naught I divided by 4 pi r. Then we say 1 plus root 2 divided by root 2. This will be the net magnetic field. Okay. Let's suppose if you have this question. If they ask you to find the magnetic field at the center, what is the magnetic field due to this loop at the center? What is the magnetic field due to this loop at the center? Okay. What is the magnetic field due to this loop at the center? See, magnetic field due to this loop at the center will be, listen guys very carefully. We say magnetic field due to this loop at the center will be, see, first of all, this center point is along this wire. So magnetic field due to this wire will be 0. Because if the point lies on the axis of the wire, magnetic field at that point will be 0. Magnetic field due to this wire at this point is also 0, because this point lies on the axis of this wire also. Now what remains? A square. So magnetic field due to square. So net magnetic field will be magnetic field due to square. And what is the magnetic field due to square? 2 root 2 mu naught I divided by pi into L. This is the magnetic field due to the square loop. Okay. One more important question. Okay, let's talk about this. See, if I say what is the net magnetic field over here? See guys, when it comes to the net magnetic field, this is over here. What I can see, this is over here. This is a cord. This is a straight line. This is a straight wire. This is a straight wire. So you have to find the net magnetic field at the center. Now see, I'll say over here, this structure is made up of 1, 2, 3, 4, 5, 6 wires. Clearly, I can say magnetic field due to 2 will be equals to magnetic field due to 6 will be equals to magnetic field due to 4, and it will be 0. It will be 0. Why? Because the center point lies on the axis of the wire. The center point lies on the axis of this. This center point lies on the axis of this. This center point lies on the axis of this. Okay. When it comes to the net magnetic field, my dear NEET aspirants, first you'll say, sir, magnetic field due to the cord. And this cord, it has a radius of 4r. Okay. So you'll be saying, sir, due to this cord, it is mu naught I divided by magnetic field due to a cord is mu naught I by 8r. So 8, instead of r, I can write 4r because its radius is 4r plus. What is the magnetic field due to the semicircular wire? Sir, magnetic field due to semicircular wire is mu naught I by 4r. But its radius is, I would say, 2r. So it will be mu naught I divided by 4 into 2r, then plus. Magnetic field due to this cord, so it is also going to be mu naught I divided by 8r. Okay, this is the net magnetic field. Now you can simplify it further. Take this magnetic mu naught I by 4r, you can take common. Mu naught I, okay, this is mu naught 8r, this is 2 times, by the way. Mu naught I divided by 8 into 4r plus 2 times mu naught I divided by 8r. Now further also you can simplify it. Mu naught I by 8r you can take common. In the 2 you can simplify. Okay, yes. Let's suppose you have this. This is the diagram. Okay, you are supposed to tell me what is the magnetic field due to this diagram at the center. Guys, see, in this particular case, you can clearly say this is a semi-infinite wire. This is over here an arc. Don't consider semicircle or chord. It's an arc. It's an arc. And when it comes to the magnetic field due to an arc, I'll write it over here. Magnetic field due to an arc is mu naught I. Okay, I'll directly write the magnetic field. See, magnetic field due to the first wire is 0 because this point lies on its axis. So we say net magnetic field will be magnetic field due to this arc and this straight semicircular wire. So due to an arc, it will be mu naught I divided by 2r, theta by 2 pi. And theta means this angle. Theta means this angle. This is theta. Mu naught I by 2r, theta by 2 pi. And how much is this angle? 270. That is 3 pi by 2 into 2 pi. This is the magnetic field due to an arc. Plus magnetic field due to a semi-infinite wire. Semi-infinite wire magnetic field is mu naught I divided by 4 pi into r. Divided by 4 pi into r. Okay. Now done. So solve this. It will come out to be, and this is 2 into 2. See, this 2 into 2 is 4 into is 8. So this will come out to be 3 by 8 mu naught I divided by r plus mu naught I divided by 4 pi into r. So this is the net magnetic field. This is the net magnetic field. This is the net magnetic field. I believe this is crystal and clear to each and every single student. This is the net magnetic field. Similarly, you can find this one. Guys, what is the magnetic field due to this? What is the magnetic field due to this? Okay. Guys, what is the magnetic field due to this first wire? It is 0 because it lies on its axis. Magnetic field due to the second wire. Due to this, it is also 0 because it lies on its axis. So here also magnetic field will be, net will be magnetic field due to 3. That I recently told you. Mu naught I divided by 2r. R is the radius. Theta. Theta is 2 pi. 3 pi by 2. That is 3 pi. How much it was? Theta by 2 pi. 3 pi by 2. 3 pi divided by 2 into 2 pi. This is theta by 2 pi. Pi and pi will cancel. So this is 3 divided by 8 mu naught I divided by r. You can say it like this. This is the net magnetic field in this particular case. This is the net magnetic field. Okay. Yes. Okay, just a second. What else I'm gonna show you over here? Let's suppose if you have this question. Find the magnetic field at the center. You are supposed to tell me what is the magnetic field at the center. This is basically a hexagon. This is basically a hexagon. And in this hexagon, it has got how many sides? 6 sides. Hexagon has got 6 sides. So here current flowing is I. Current flowing is I. This is 6 sides hexagon. What I want you to understand in this particular case, my dear NEET aspirants, what is the net magnetic field at the center? See, you find magnetic field due to one wire, then multiply with 6, you'll get net magnetic field. Okay. So magnetic field due to this one wire, magnetic field due to this one wire. Guys, in case of hexagon, this angle would be 60. This angle would be 60. Okay. This is what we do in case of a hexagon. Okay. Yes. Now, my dear NEET aspirants, okay. What I want you guys to do in this particular case, oh, sorry, this will be 30 and this will be 30 because total is 60. This angle would be 30 and this angle would be 30. Total is 60. So you find magnetic field due to this one wire. So here in this particular case, theta 1 is 30. You find due to this wire in which current I is flowing. Theta 2 in this particular case is also how much? 30. And R will be L. Okay, R will not be L. R we have to find out. R we have to find out. Okay. Now guys, in this particular case, if I say, what is the value of cos 30? Cos of 30 is base upon hypotenuse. If you take this triangle, base is R, hypotenuse is L. R divided by L. So R will be L cos 30. Cos 30 is root 3 by 2. Root 3 L by 2. This is L. This is R. Now find the magnetic field. You can use this formula. B is equal to mu naught I divided by 4 pi R sine of theta 1 plus sine of theta 2. So you can say B is equal to mu naught I divided by 4 pi R. Instead of R, you can write root 3 L divided by 2. Then sine of 30 plus I would say sine of 30. 2 ones are 2 twos are 4. B will be equals to mu naught I divided by 2 pi root 3 into L. Sine 30 is 1 by 2 plus sine 30 is 1 by 2. Okay. So B will be equals to mu naught I divided by 2 pi root 3L, and this is 1. This is the magnetic field due to one wire. But how many wires are total? 6. So you say magnetic field due to 6 wires. It will be 6 times of mu naught I divided by 2 pi root 3 into L. 2 ones are 2, 3s are 6. So this will be 3 mu naught I divided by root 3 pi into L. Okay. This you can say it like this. So this will be the net magnetic field in this particular case. Okay. Due to this wire, magnetic field at point P is 0 because the point lies on the axis of the wire. Here you have got 2 wires. What is the magnetic field due to this wire at point P? Magnetic field due to this is 0. And for this, it is a semi-infinite wire. And what is the magnetic field due to a semi-infinite wire? Mu naught I by. So net magnetic field will be mu naught I divided by 4 pi into R. Due to this, field will be there. Due to this, there will be no field. Okay. Yes. This I am giving you as home. By the way, this we did already, na? What is the answer to this question? This is a previous year question. What is the answer to this question? There is a wire. Here angle is making 60 degrees and this will be R. See. Let me just give you the idea. You have to tell me what is the magnetic field due to this wire at this point. At this point. See, this is going to be the value of, R. Okay. This is cos 30, this is cos 30. This is 30. This angle is also 30. And this is R. This is R. And recently I told you R will be L cos 30. Or here it is X cos 30. X cos 30. So R will be equals to X root 3 divided by 2. And theta 1, theta 2 is this. What is the magnetic field? Mu naught I divided by 4 pi R. Instead of R, it will be X root 3 by 2. Then sine 30 is 1 by 2 plus sine 30 is 1 by 2. Sine 30 plus sine 30. Na? 2 ones are 2, twos are 4. Magnetic field will be mu naught I divided by 2 pi X root 3. 2 pi X root 3. Do one thing, multiply with root. Okay, no. 2 pi X root 3. Okay. I think this is matching. Yes, this is matching. Option first. Option first is matching. It is like this only, na? It is like this only. Yeah, it is like this only. This one. It's like this only. Hexagon case. This you can do it from your end. This is your homework I can give. This is simple. Here theta 1 and theta, this is theta 1 and theta 2. It is not given, but you can calculate theta 1. This angle is 90. What is the value of theta 1? Guys, sum of total angles is theta 1 plus 90 plus 30 It will be equals to 180. Sum of all the angles in a triangle is 180. So if I say what is the value of theta, 90 plus 30 is 120. And see, this one plus this one plus this one will be this one. So if you have to find the value of which, 90 plus 30 is 120. 180 minus 120 is 60. Okay. So theta 1 will be 60. So theta 1 in this particular case will be simply 60. Okay. And here theta 2 will be similarly. If this is 60, this is 90. So what will be this? This will be 30. Now you got this one. Now you can apply that formula. Mu naught I by 4 pi r theta 1 by theta. Mu naught I by 4 pi r sine of theta 1 plus sine of theta 2. Okay. So guys, that's all for today in this session. Let's see you in the next session. Okay. Thank you for this. Okay. Take care and bye-bye.